We are going to pick up where we left off yesterday, and that is we were smack dab in the middle of requiring the user to enter the correct password before they could do the simple interest calculator. Does that sound familiar? So everybody get that program up, and we'll be good to go. Libby, go on YouTube and go to my YouTube channel, and I just want to see if that actually uploaded yet.
Who's uploading this?
Evelise.
Okay.
I'm going to just show everybody if it is.
Man, this is
Slow.
really slow. Okay. I don't know what you're. Is it?
Type in Dean Johnson calculus, and that should get to the main one. And so you can click on me up there. And then computer science
This
is,
one?
yeah.
Oh, this. Yeah.
Play it. Does it sound
Really terribly quiet. I don't know.
Skip this one. Okay, everybody. I just want to demo something while this is still going here. As you know, I'm swiveling this class. That means that I'm recording this class, and the videos for the class are being uploaded to YouTube. Okay, so I want to show you how to get there so that in case you're gone or you want to re-look at a lesson, all you have to do is go to this place. So everybody go on Chrome and go on to YouTube. And on YouTube, what I want you to do is do a search for Dean Johnson calculus. Okay, that's what a tag is right now. That'll catch it. And I'll give you one guess to picture which one that you should select. Okay, this is my channel. So you can click on my YouTube channel. And there's multiple, I don't know, there's like 50 videos or so. But if you look here, there's playlists here, which is where we're going to put all the computer science too. But then I have playlists for the calculus ones too. And we only have one video in there right now. So you can click on the computer science too. And go ahead and just play it. Play the first one. There's only one there, right? And you can skip through it. And there's audio and everything. The one with Jamie, where she's doing the thing. Yeah. Now, what I would actually recommend that you do is subscribe to my channel. So if you're on the main screen, you can hit that little red button that says subscribe, That way, anytime I get new lessons up, you can go ahead and, you'll get an email that just says, hey, there's another video that's out there.
I just watching.
So, okay,
You said let's get going
a lot. I have to think of a new
No, I think
Catch-
that should be your
catchphrase.
your tag. Alright, let's get going.
Let's get going here. All right, let's roll. I say that too a lot. Okay, so that's available for either. Now, I can see two uses for that. Either a review if you want to just say, all right, I want to just hear that again. Or, most especially if you're absent, you can just go ahead and review that. Okay, so, but I'm going to be recording every time that I'm teaching a lesson. So I hope you find it helpful and useful, and please subscribe to my YouTube channel. That's a plug. Okay, well, let's move on. So go back to, you can close out YouTube so you're not obsessing over my videos. I know they're very, very, desirable, but let's go back to Java. So here's where we stand. We're looking at this program, and the goal of the program was right now is to have the person enter a password before they are allowed to move on. And we said we were going to do hello as the password. Now, I'm going to do a little thing over here on the side, and what I'm going to do right here is what's called an algorithm. And when we look at an algorithm, it's more or less us just thinking out loud, how do we want this to work? Okay? Programmers always use algorithms prior to writing code because it helps them actually think about what they're going to do before they do it. Okay? So, here's what I want. I want to say enter a password, and then they enter something. Okay? But let's suppose they get it wrong. Okay? They get it wrong. What I want to do is I want to say something while the password is not equal to the real password. While what they enter is not equal to. Now listen to this. While what they entered is not equal to the real password, we want to tell them that they're wrong. They entered the wrong password. And we want to tell them, hey, enter password again. And that's going to repeat over and over and over and over until they get it right. The key here is that it's not equal to. Okay? So, in this program, what we've got right now, we say, while the password is equal to hello, so what we want is not equal to, and this is how you do a not equal to a string. I put an exclamation point right here. This means that as long as the password is not equal to hello, this means that the user entered the wrong password. I'm following my algorithm over there, and now I'm writing the code. So according to my algorithm, I'm going to say I'm going to tell them that they're wrong. And let's really tell them it's wrong. It's very harsh. And then let's have them enter the password again. So I want to distinguish the first one from a little bit from these. So I'm going to say enter the password again. That way we can tell the difference between this prompt and the prompt that we did originally. Now we have to just get the password. So what are we going to do? How do we get the user's password from the user? What are we going to use? Shout it out. We're going to use a scanner. Now, wait a second. Does this look right? Why is this wrong? Right. This creates another variable, a new string, called password. This is wrong. We do not want to create a new one. We want to use the same shoebox that we had before, which stores the value. So do not put string in front, because that creates a brand new variable. We're going to recycle that password variable. And then we have to use that scanner that we used for all of the string variables. All right, go ahead and run it, and let's see if this is good. So I put my output over here. I just dragged my thing over here. So let's suppose I get it right the very first time. And so that means I can move on. And let's pretend we don't want to go. So we're there. So the normal circumstance looks like it works. Now I'm going to run it again and get the password wrong. And then get it wrong again, wrong again, wrong again. Okay. So this is going on and on and on until, and then we're good to go. Okay. Is everybody's program working? If it's not, compare with people next to you first. Talk to each other. Programmers always help each other out. Always. Okay, can I move on? All right, let me introduce you to the infinite loop. The infinite loop is a bad, bad thing. Okay? All right, I want you to comment out this right here, this line where we get the new one. Comment this out and run this program again. It's my line 31. Comment that out. All right. If you get it wrong the first time, you really get it wrong. Okay? This is called an infinite loop because we're stuck in this thing where it's continuing and continuing forever to go on. But the question is, why is it doing this? It doesn't have a scanner. Password is never replaced. It's never going to equal hello ever. So it loops through this, and it'll never stop, ever. Okay? Now, in your console, there's a little red box right here. Okay? Little red box. Press that box right here, this red one. It's in your console. It's just the spot where this is. This should stop it. Okay, so press that red square, and that stops the program. Okay. So here's the lesson learned. Whenever you're in a while loop where you're going to compare against something that the user enters, make sure that you allow them to enter the value inside of the loop. If you don't allow them to enter that, you'll get an infinite loop. In other words, what you're comparing against in the while loop has to be able to change. If it doesn't change, you are in infinite land. All right, so to put that back, now let me show you another way to get an infinite loop. But this one's a little bit trickier, and it's very accidental that you can get this. I want you to put a semicolon right here at the end of your while loop. It seems so innocent, doesn't it? Not a problem. Semicolon right there. Go run your program and enter the wrong password. The difference here, this is also, your program is in an infinite loop right now. But you can't really tell. The only way you can tell is you can see the red box right here. It means the program's still running. And let me try to explain what it's trying to repeat. By the fact that you put a semicolon there, that means it's going to repeat this. It's going to repeat nothing. Okay? You're telling it to repeat this right here. Because the semicolon is a separation of the instruction, and the while loop should have the curly braces to say this is what I want to repeat. So we are repeating nothing infinitely. This program will never stop, ever, till the computer crashes, or we turn the power off, or we press the red X, or the red square. All right, so stop this program by pressing the red square, terminating that, and put this back to normal, which is right here. So, lesson learned here, don't ever put a semicolon on the end. Okay?
That's what we feel, and I just figured out.
Oh, that's what you had.
Yep, that's why I was working.
Okay, and remember that the exclamation point means not. If you accidentally said take off this, accidentally take off the not, and we're going to say, while the password equals hello, do this. How does this change how the program runs? I took off the semicolon, not the semicolon, the exclamation point, which now we're saying while the password is equal to hello, do this. What's that? And now we'll run the program and then put in the correct password. Oops. And you're like, wait a second, that's the correct password. So you type it again. I swear I'm typing the right password. And then you only get in if you type in the wrong password. It's such a subtle difference, but the computer will do exactly what you tell it to do. And that's the difference between putting the not here and not putting the not there. Okay? So the correct way to do it is we want to repeat this as long as the password is not equal to. So that's why the exclamation point needs to be there. Does that make sense? Okay. I think let's put this program to rest. You have now several things going on here that you can build off of. I've taught you different tools here, how to use the while loop, how to use the or statement, and so on. Okay, so we are going to move on. Okay, let me describe where we're going to go next. And so I'm going to blank you out so you can all pay close attention to what's going on. So let me describe the new program. Okay. Actually, let's just move this over here. Yeah, we did that in the or, but you can also use the and as well. Okay. All right. So try to think of another program that we can use lots of different tools for. And I thought a fun one would be a simulation of flipping a coin. Okay? Seems appropriate if you're a Packer fan. Maybe flipping a coin would be good. Did you guys see that? I watched the they had the flip cam. It was so weird. The referee flipped the coin and it never flipped. It went up and then it went down, and even when it hit the ground it didn't turn over. It was the weirdest thing. Okay? All right, so I want to write a program that that does a simulation of flipping a coin. Okay? So I want you to pay close attention to what I'm doing here because I'm modeling for you how you build a program from scratch. So, but you're going to help me out here. How many times do you want to flip the coin? 3 times? A random number? That's good. So we can make that a variable of some kind. We can assign it any way that we do it. We can determine how many times we're going to flip it. Okay. Now the question is, how do we pretend we're flipping a coin when we don't have a coin? We're just doing this on the computer. That's a question. We need some sort of random thing that's going to go on here. And so we have to pick a random number. somehow, which I'm going to show you. And then we're going to decide if it's head or tails. Okay, so we're going to have to figure out how we're going to decide to do that. And then we need to keep track. Okay, I want to keep track of how many that there are. Okay, so I want to count how many of each flip do we have. Because really, what I'd like to do is maybe flip it 1,000,000 times and see if it comes out 50-50. You know what I'm saying? Because realistically, if we do a correct simulation, it should come out to be about 50% each side. Okay? So I want to be able to do this as well. And then maybe I want to repeat this as many times as they want to. So I want to repeat this if it's desired. Okay? So what we're going to do is we're going to build a thing that will allow us to flip the coin. We're going to flip the coin once first, and then after that we're going to I'm going to show you how to do it multiple times, and then kind of keep track of everything. And I can't stress enough that what I'm trying to do here is show you how to do things in general, because rather than giving you anything super specific. Okay, let's go in and let's start this program. So, all right, let's do this. You should all have a package called Group 1, okay, where your programs are in this package, okay. So we're going to right-click on Group 1, and we're going to make a new class. So right-click on this package, and we're going to go to New Class. Because when we create a new program, it's called a class. And classes always start with an uppercase, so we're going to call this flipACoin. And because we can, we're going to put the public static void main in. And there's nothing that we don't have any of those. So you can uncheck that if it's checked. I think by default it is. But we end up not even doing it because we don't have that. So checkbox those two. Click on finish. And you should get a program that looks like this. So right off the bat, let's do a couple things here. Let's identify what the program does in this top comment. So this program simulates flipping a coin. And then we're going to delete this multiple line comment. That's not necessary. So you can delete this one. And you can delete this first comment here. And you don't have to, but I'm going to put these curly braces on the new line. So I'm saved and I'm ready to roll. Okay. We good? Okay. What I'm going to do is I'm going to show you how to use a random number. So use the random method from the math class. So what we're going to, I'm just going to go out and type it in, and then you can, and then explain what is going on here. Let's call it, I'm going to create a variable. It's a double. It's called rand. It's just short for random. And it's going to be equal to a number selected at random by the random method of the math class. And we're going to print this so you get some kind of feel for what it's doing. So the variable rand is a double, so it can hold a decimal, and it's being assigned a random number by the math class's method random. And all we're doing is printing it. So if you run it, you go ahead and run the program. You should just get some random number. Okay? If our two numbers are ever equal, I think we should just go out and buy lottery tickets right now. Okay. So run the program. Now remember, when you run the program for the very first time, you should right-click on the program itself and then do run as application, Java application. But then after that, you can just press the green button with the triangle on it. So run this a bunch of times after you've run it once. And if you run it multiple times, what you should see is that there's a different random number each time. Mm-hmm. Now, tell me, can you describe the kind of numbers that you're getting? What's it? Can you describe the numbers? Yeah? In between 0 and 1 is the correct answer. Okay? Now, the deal is, it could possibly be 0, but it can never be 1. So, just so you know, let's put a comment in here. Between 0 and 1, including 0, but not 1. So you could run this a million times, and you'll never get a number that's equal to 1, ever. Okay? Okay. How the heck can we make this into flipping a coin? How is it possible that we're picking a random number, and it could be anywhere between 0 and 1. How could we use this to have the computer make a decision as to whether or not we have a heads or a tails? Yeah.
Well, we made it so it's the first digit unless it's odd.
Oh, okay. That's a good call. We could look at the first digit and see if it's whether or not it's odd or even. Do you think we've got a 50-50 chance? Probably.
Yeah, sometimes the first digit's 0 actually.
But 0's even, so that's okay. All right, that's actually not bad. It would take a little bit of programming to extract that first digit, though. You can multiply that number by 10, and then you would be able to just tell if that first one was. Okay, that's very good. Okay, keep those in mind. We might come back to those.
Is there any way you can do like a random number that's like not included?
Yes, we can modify this statement right here. But I want to use this alone. Stop and think.
Less than or equal to 0.5.
0.5 is like halfway in between, right? So we could actually double check. We could say, hey, if the number is greater than 0.5, it's going to be a head. If it's less than 0.5, it's going to be a tail. Okay? So let me show you how we're going to do that. It's the simplest way that we can do this. So watch this. We're going to say if, and now this is the if statement, a decision. If, if rand is greater than or equal to 0.5, and then put your curly braces. So if the number is greater than or equal to 0.5, let's just randomly state that that's going to be heads. And then watch what I'm going to do here. I'm going to put an else statement. And this is where we're going to say it's tails. Now back in Alice, you might remember the if-else, where there were two different blocks. If something was true, we put it here. If something was not true, we put it here. This is exactly the same. Make sure your curly braces are matching up. This part and this part. So if the number is greater than or equal to 0.5, we're going to call it a head. And if it's not greater than or equal to 0.5, we're going to say it's a tail. So we can easily do this by just putting a system.out.println here. And we'll call it heads. And here, we'll call it tails. When you get this, go ahead and run it, and then run it and run it and run it, and tell me if it's working. Because if this number is greater than or equal to 0.5, it should say heads. And if it's less than, it should say tails. Yeah.
I'll switch to run. So I can't really run.
Yep, you gotta, hover over the X.
Well, I'm just missing semicolon.
Yep.
Well, no, it's just when I run it, I end up doing this interest calculator.
Yeah, the first time you run a program, you have to right-click on it and say run as. Oh, yours. Go save it. Saved. This is your package. Alright, let's go out here. Simple interest. Why is it do? Did you copy and paste?
I may have.
Yeah.
Well, I made a new class and then didn't do anything about it.
Okay, type in the word public right here. Don't copy and paste. Have it generate a new class every time.
Do that whenever I run it.
Because it knows. Look at here. Because it knows if it's not this, it has to be this. We don't have to check it again. Okay, is everybody's running? Yes, 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 yes. Okay, so we're successfully able to flip the coin and determine whether or not it's heads or tails. Let's do this a lot of times. Okay, let's flip it a lot. Okay. So let me show you something. Let's just flip it 10 times. And I'm going to show you how that we're going to do this. What I want to do is I want to repeat. This is where we actually do the flip. So maybe I'm going to put a comment in here and I'm going to say do the flip. All right, I'm going to flip it 10 times. Let's just flip it 5 times because then we can see this a little bit better. So I'm going to teach you how to kind of keep track of how many times that we flip it. So I'm going to create a variable, an integer, called counter, and I'm going to set it equal to 0. Okay. And then I'm going to say, while the counter is less than 5, and then watch, I'm going to put a loop in here, so I need a curly brace for the while, so I'm going to put a curly brace here, and I'm going to put a curly brace after the flip. And I'm going to shift all this over to the right. So look carefully at what I got here. Counter, int counter is equal to 0, while the counter is less than 5, and then I put a curly brace here and here, and then I selected what was on the inside, and I did a shift right under source. Okay. Now, go ahead and run the program. Now wait a second, we got ourselves an infinite loop here. Okay? But I'm thinking, well, wait a second, I'm doing the flip, aren't I, over and over? How come it's going on forever? And how come it always says, mine always says heads? Does yours ever change? Say it again. Okay, what's the value of counter? 0. Does it ever change? No. So it's never going to be greater than 5. So what we forgot to do here is change the value of counter. We want to just add 1 to it. And the other thing I think we forgot to do is we forgot to do the flip inside the loop. Okay? All right. We're going to stop here in our infinite loop. So stop this, and then we're going to pick this up and fix this tomorrow. Okay, so we know this doesn't work, and we'll be coming back to fix it tomorrow.